Hello everyone, today I'm going to be talking about finding triangles that you can use for problem solving when you are asked to problem solve within 3D shapes. So the shapes I'm going to be going over in this video that are often appearing on further view questions are the right pyramid, which is a square-based pyramid, which the center is, like the apex of the pyramid is directly above the top of the rest of, like the center of the base of the pyramid. Hence it is a right pyramid. So if I may draw that in a more detailed manner, you get something like this. Right, and basically in this pyramid they may give you values such as the length here, the height here, the width of the base, and so on and so forth. Then basically there are just a few common right angle triangles that you need to know to help yourself problem solve in this kind of pyramid. So say if I want to draw it more accurately, I'm going to draw it like this. And then say if this is the midpoint of the whole thing, I'm going to go up 4 spaces. Okay, so imagine that is a square pyramid. Every angle here is a right angle. This is kind of distorted because we have a 3D shape on a 2D plane. But basically, the first kind of triangle you use is to calculate this length here, or this length here, between a corner of the base and the center of the base. And basically, if you take a look at the base as a square, and you have your center here, this right triangle would be halfway along this side, and then all the way to the center, and then these two will have the same length, and then you get this length here. And this is a 45, 45, 90 triangle. And alternatively, you can just use the Pythagoras theorem to get this length, but then this length is important in another kind of triangle in the right pyramid. So secondly, another kind of right triangle that you can use in the pyramid is that of the center to the edge of the base. So say you have your center coming at you, and there's the apex of the pyramid here. Then you have another line going to this midpoint of a side of the base of this triangle, and this is basically a way for you to figure out the length up a face here. So like this length here, we'll call it L2. You can figure out stuff using this triangle, and stuff that you can figure out also includes the angle between the plane of this triangle and the plane of the base of the pyramid. And basically, if you haven't known before, a plane is the, like, for any 3 points in the 3D universe, there is a plane, like a sheet of that 3D universe, which runs through all 3 points. So it's like, imagine with 1 point, there's always a point there, and with 2 points, you get a line. And then in the 3-dimensional universe, with 3 points, you get a plane. Alright, so this can lead us to know that for basically any kind of right triangle you can construct in a pyramid, or any other kind of shape like that, you can know exact details about it, and that can tell you details about the 3D shape as well. So the first triangle here, which is important, is the corner of base to center of base. The second kind of triangle here, which is important, is midpoint of side to apex. And you can combine this triangle and this, not this triangle basically, but you can use part of this triangle to get information about the length up the vertex here. So for example, say you have like the edge there, say you have your base again, and there's the center point here, and the tent pole in the middle is coming up out here, the height is coming up like this, and then the triangle we are looking at here is basically this triangle here, where we know there's going to be a right angle here, and then this is going to be like a root 2 if one side is 2a, and then you have like the height here, and you can figure out finally what is the length of these like corner pieces that are coming to this pyramid. And less commonly with pyramids, you also get occasionally pyramids where the angle of the apex is 90 degrees. So you'll have a really big right triangle here, but this is very rare. You have a really big right triangle here, and there's a right angle there, and you can use it to find information about basically all of the sides and stuff, because you know that this is going to be, like if this length is a, you know that the side of the base is going to be a over root 2. And if you know this is a over root 2, well, it's likely that this is going to be the same as well, because a over root 2 squared is a squared over 2, and a squared over 2 times 2 is a squared, and you root that and you get 8. So basically in a pyramid where this is a right angle, you get every outside vertex is equal to some same value, a over root 2. So that's quite an interesting thing to think about, really. So yeah, we have the first triangle here, which is entirely on the base, the second triangle here, which is basically from the highest point in the pyramid to the midpoint of a side, and then the third triangle here, which is from the highest point in the pyramid to a corner of the base. And these three right angled triangles that you can identify in a pyramid are absolutely important to use to being able to problem solve properly. Alright, so now we've wrapped up that about pyramids. I'm going to talk about the other kind of shape they use in 3D trigonometry and further pure, and that is the cone. So cone is somewhat easier to draw, I think, because it's simply two lines like so, connected by a circle at the bottom, and that makes my job easier. So obviously I like it. And basically a cone here is going to have a back side and a front side. And basically this cone here, for cones they can sometimes give you the angle here as if you are taking a triangle straight out of the cone like this, which gets rotated around to make the cone, but then basically they're just taking a slice right down the middle of the cone and they're giving you this angle here. I know that's happened before in a question, and basically you can divide this into two right angle triangles, which you utilize here, and this angle will be half of the angle in the tip, and so on. And that's basically what you can know from a cone. And finally, some tips upon like questions where they'll ask you to find the angle between two planes. Try and construct a triangle between two planes such that the plane of the triangle is perpendicular to the plane of both planes you're trying to find the angle between. So that's kind of a convoluted and messy statement, but the best way to understand this message is, say you have like a book and you have one page flat on the table like this, and you have another page in the air like this. So say you wanted to find the angle between these two pages. What you'll want to do is construct a triangle, which, if I'm going to switch to a different color to make it clearer, construct a triangle which goes from a point here down to here, and then here to here as well, and here to here. But the thing is, at any point in the triangle, you want there to be a right angle between the triangle and the page. And at any point, as long as the triangle is making a right angle with the surface of the page that you are trying to get, then that means it'll be completely like straight up, and you can use the triangle as a 2D representation of the 3D object. So like if I wanted to find the angle between these two books and I knew some information about the dimensions of the book, say this height h would be the same as this length h, or this length g would be the same as this length g, and so on and so forth. So basically for 3D trigonometry and 3D problem solving, the key point, use a triangle. No matter what kind of question it is, if it's a trigonometry question, often there will almost always be a triangle available for you to spot in the question and use information about. So that's my advice. Find a triangle and use it, or find a square and use it. Anything. Find a 2D shape that accurately represents the properties of the 3D object in detail, and solve stuff on the 2D shape instead of the 3D shape. It'll save you a lot of hassle, and that's kind of the method that people would use to solve it. Alright, so thanks for watching.